study of moving coil ballistic galvanometer. So here the principle of galvanometer is that it measures the quantity of charge passing through the coil. And now this charge passing through the coil will be directly proportional to the maximum deflection produced by the coil. So in order to calculate this, let us consider a single turn coil PQRS placed in uniform magnetic field produced between the north-south poles of powerful horseshoe magnet. Let I be the current flowing through this coil in the direction P to Q, Q to R, R to S and S to P. Now let the length of the sides PQ and RS be B, and the length of the sides PS and QR be A. And now here if we consider PQ and RS phase, these both phases are parallel to the field direction. And now as PQ phase is parallel, now the force acting on the phases will be equal to BIL sin theta. As PQ phase is parallel to the field direction, the angle between PQ phase and field direction will be equal to 0. Sin 0 will be 0, the force will be equal to 0. And similarly, here if we consider RS phase, this is also parallel to the field direction, but the current is flowing from R to S, that is opposite to the field direction. So the angle becomes 180 degrees. Sin 180 will be equal to 0. So here also the force acting on RS phase will be equal to 0. So net force on PQ and RS phases are 0. Now according to Fleming's left hand rule, on PQ phase force will act in upward direction, okay, in such a way, and on RS phase force will act in downward direction. And here the line of action of forces is the same. So the net torque due to these forces will be equal to 0. Now let us consider the phases PS and QR. These both phases are perpendicular to the field direction. So as these are perpendicular to the field direction, angle will become 90 degrees. So the force will be equal to BIL. Now let as the length of PS is equal to QR is equal to A, the force on PS phase and force on QR phase will be equal to BIA. And according to Fleming's left hand rule, the force on PS phase acts inwards towards the plane of paper, into the plane of paper, and the force along QR acts outwards from the plane of paper. So see here, one force acts inwards, other force acts outwards, and line of action is also different for these two forces. So now these two equal opposite directed parallel forces having different lines of action constitute a couple, and this couple deflects the coil. If n turns are present in the coil, then moment of deflecting couple is written as NBIAB, where AB is the length and breadth of that PQRS coil, and that is nothing but equivalent to area of cross section of the coil. So now the moment of deflecting couple or torque acting on the coil will be equal to NIAB. Now the torque acting for infinitesimal time dt gives angular impulse, which is nothing but the product of couple into time, that is equal to NIAB into dt. Now if t is the total time, then total angular impulse will be equal to integral 0 to t NIAB dt. So we wrote this as NAB integral 0 to t I dt, that is equal to NABQ. Now we know that current is nothing but equivalent to dq by dt. So I dt becomes dq. So integral 0 to t I dt is equal to q. This only we substituted in above equation. So angular impulse became NABQ. But angular impulse is equal to change of angular momentum. Okay, angular impulse, which is nothing but equivalent to change of angular momentum, which is equal to product of moment of inertia and angular velocity, that is I into omega. So now here angular impulse we got as NABQ, and this will be equal to change in angular momentum I omega. So NABQ equal to I omega. Let us take it as equation 1. And now we know that kinetic energy of moving system is equal to half I omega square, where I is the moment of inertia, omega is the angular velocity. Now already we said that the couple will deflect the coil. Due to the deflection of the coil, a twist is produced in the wire, and such twist will be directly proportional to the couple. So now the couple for the twist theta will be equal to C into theta. Let us give some additional twist d theta for the coil. So now the work done for giving additional twist d theta will be equal to C theta d theta. Now if theta naught is the maximum twist produced, then work done will be equal to integral 0 to theta naught C theta d theta, where theta naught is the maximum twist produced in the coil, in the wire. So that is equal to half C theta naught square. Now half I omega square equal to half C theta naught square, or I omega square equal to C theta naught square. Let us take it as equation 2. Now the time period of oscillation of coil T will be equal to 2 pi under root I by C. Okay, and now squaring this, T square equal to 4 pi square I by C. Now from this we get moment of inertia I equal to T square C by 4 pi square. Now let us square the equation 1 and divide it with 2. Then we get n square a square b square q square by C theta naught square equal to I square omega square by I omega square. Now from this we got I equal to n square a square b square q square by C theta naught square. Let us take it as equation 4. And now substituting the I value from equation 1 in equation 4, we get T square C by 4 pi square equal to n square a square b square q square by C theta naught square, or T square by 4 pi square equal to n square a square b square q square by C square T naught square, C square T naught theta naught square. Now this becomes T by 2 pi is equal to NABQ by C theta naught. From this the charge Q is written as T by 2 pi C theta naught by NABQ, or Q equal to K theta naught, where K is the TC by 2 pi NABQ, which is nothing but a constant for galvanometer. So from this we can write Q proportional to theta naught, that is the charge passing through the moving coil galvanometer is directly proportional to the maximum deflection produced by the